So now we are going to see about that logical circuit. So before moving into that logical circuit, first of all we have to know about that Boolean expressions, because by using that Boolean expressions only we have to solve that logicals with the help of De Morgan's law. So we have to solve the Boolean expressions with the help of the De Morgan's law. So first one is that a Boolean expression. So Boolean expressions is a logical statement, so that can be either the true or false condition, that means the 1 or 0. So Boolean expressions can be compared that any types of data as both as parts of that expressions having the same basic data types. This is called as a Boolean expressions. The Boolean expressions can be solved with the help of a logical gates. So there are many types of gates are available. The main basic gates types are AND, OR, NOT, and the next gates types are that NAND and NOR. So by using these gates only we have to solve the Boolean expressions, that means the logical conditions. So from manufacturing point of view, only one type of gate is easily used to implement the circuit. By using with the help of that gates types only we can implement the entire circuits. Okay, so the gates are the basic building block of all digital system. It can be implemented with the help of using that electronic components, that means either the transistor, diodes or resistors. So the different types of gates are AND, OR and NOT. The first type of gate is OR. OR function means it can perform that addition operation. So 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1 and 1 plus 1 is equal to 1. So and the next type is that AND function. AND means it can perform that multiplication operations. So 0 into 0 is equal to 0, 0 into 1 is equal to 0, 1 into 0 is equal to 0 and 1 into 1 is equal to 1. And NOT functions means it just that opposite of that input function, that means the 1 implement is equal to 0 and 0 implement is equal to 1. So these three gates are the basic types of gates, okay, AND, OR and NOT. And next one is that the combinational circuit. So combinational circuit, it is mainly useful for many number of the devices. So now we have to solve that half-adder circuit with the help of some basic types of input functions. In that input it can perform that OR operation. So OR means it can perform that addition operation. So we are taking the input as X and Y, 0 0 1 1 and 0 1 0 1. So now with the help of an half-adder circuit we have to solve that sum and carry parts. That means sum means now we are going to perform that OR operation. OR means plus. So 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 0. That means the carry part is 1. So here we are performing that OR operation. This is that output for that half-adder circuit. And that is that Boolean expressions. So we have to apply the De Morgan's theorem to that Boolean expressions. So De Morgan's theorem is, it can state that the complement of a conjunction is the disjunction of that complements or vice versa. That means not of X and Y is equal to, that can be write it as a form of not X or not Y. Not X or Y. That means it is equal to not X and not Y. So not X and not Y. So not is common to both that X and Y. So it is the De Morgan's theorem, and these are the basic De Morgan's theorem. So first one is that X plus 0 equal to X. Anything plus 0 is equal to some same as that input function. And X plus 1 is also is equal to 1. Anything plus 1 means it is equal to 1, and anything plus 0 means it is equal to that anything function only. And X plus X is equal to X. So same, anything plus anything is equal to anything. So likewise, and X plus X complement is equal to 1. That means A plus A complement is equal to 1. Okay, and X plus Y is equal to Y, Y plus X, and X plus Y plus Z. Now already we said no, so X plus Y plus can be form it as plus Z. So X into Y plus Z is equal to XY, then x is z. So x is common to both that y plus z, and x plus y dash is x dash and y dash. So these are the basic theorems of De Morgan's, and x dot 0 is equal to 0, x dot 1 is equal to x, x dot x is equal to x. So this is that basic De Morgan's theorem. By applying these De Morgan's theorem only, we have to solve that Boolean expressions. So this is the expressions we have to solve, that is f is equal to a b c plus a b c dash plus a dash c. That means a b is common to both these functions, so we have to take this a b as common into c plus c dash plus a dash into c. So c plus c dash is equal to x plus x dash equal to 1, no? So c plus c is equal to 1. So ab into 1 plus a dash into c. So ab plus a dash into c. So we have to draw this expressions as a logical diagram. So we have to, the input functions of f is a, b and c. So a, b, c, it can performs that AND operation. Next one is that AB. So we have to give one that AB and A dash E. So all these functions, that means ABC as one input function and AB, C dash. C dash means we have to give one that NOT function and A dash the NOT function plus C. So there are 3 types of AND gates are available. After that we have to perform that R function. R means plus. So we have to perform that R function and we can get the output of f. So by using that we have to perform that K-map. K-map is that kernel of map of an input digital logical circuit. That means the end variable of that sum of that product form of Boolean functions. First of all, it can be divided into 2 power n cells. It can form as a rectangular shape only. So each cell can be associated with that minterm. So an output function is also a value for each input value. That means 1 is equal to cell and 0 is also a cell. So this is that a K-map function. So it is that input function 4 zeros and 4 1 and 2 0 2 1 and 0 1 0 1 f function. So f means ABC plus ABC dash plus A dash C. So by applying these input to that functions, and we can get the output in the form of 0 1 1 0 1 0 0 0. So we have to form a K-map table. That means x y z. That means 0 and 1. There are 2 inputs and 0 0 0 1 1 1 and 1 0. That means 0 0 0 0 0 0 can performs that 0. Yes, and 0 0 1 0 0 1 can performs that 1, and 0 1 1 0 1 1 can performs that 0. So we have to, that means 0 and 0 1 1. So 0 1 1 0 and 0 1 0 0 1 0 is 0. Okay, and 1 0 0 1 0 0 is 1. 1 0 1 is that 0, 1 1 0 is that 0, and 1 1 1 is also 0. So we can form a table in the form of this one and this one and this one. Yes, so summation of sum up of 1, that means this one, and 2 and 4. So this is that basic logical and K-map diagram of a De Morgan's theorem. So by using with the help of Boolean expressions, we have to apply that different types of gates. After that we have to apply the De Morgan's theorem. By using the De Morgan's theorem, we have to solve that logical diagram, and we have to form a K-map, and then we have to form a table. Thank you.